All right, so welcome to the very first workshop. Like we said, this is the first time we're going to be trying to record them, put them up online, so please forgive if we have any technical difficulties. So first things first, this is going to be in Unity. If you're at a desktop, you should already have Unity pre-installed on there. If you're not at your desktop, make sure that you have Unity installed. So I'll just go over and open up Unity right now. And as of Unity 5, this is the sort of page you should get. We are going to want to make a new project. So is everyone here at this point? We got to make sure everyone's got baseline Unity all set up. Okay, like we said, if you fall behind, just let us know and we'll try to get you back on track. So we're going to make a new project, and we'll call this one just Unity Tutorial, and you can put it wherever, your documents, wherever you want. This setting right here is just a switch between 3D and 2D. We're going to leave it as 3D for now, even though it's an introductory level workshop. We are going to be doing some 3D stuff. So then we can just go create project. And then Unity will think for hopefully not too long. And then we'll be greeted with the really familiar Unity editor, if you've opened it up before. So I guess the first thing that we'll go over is the interface. And so the interface can be broken down into three basic pieces. This toolbar up at the top, a bunch of buttons, and then a bunch of tabs. So this is your toolbar up here. This has got a bunch of really quick, easy to access things. Then you've got a bunch of buttons up on the top row. These will all be used a little bit later. And then the most important part are these tabs. We've got a hierarchy tab, scene tab, gain tab, inspector, project, console, a whole bunch of stuff that we'll be using a little bit later on. So we'll go over these one by one, starting with this scene tab. This is a representation of what's going on in your Unity scene. The way that Unity has things set up is it's sort of a content-first game engine, so it focuses around on what's going on in your scene. Do you have a question? What was that? Oh, yeah. This mic is not on right now, actually. Hello, hello. Does that work for everyone? A little bit louder? More? Is it on now? Is it on? It's on max now. Oh, wrong one. How about now? Oh, yeah. Okay, is that good? Okay, I don't want to destroy everyone's eardrums. So the scene tab is the first and probably the most important part of Unity. This is showing you exactly what's going on in your scene, per se. The way that Unity constructs a game is it's made out of several scenes. If you've used other game engines like Cocos 2D or GameMaker, you might be more familiar with the concept of scenes or levels. So what's going on in this scene tab is just a little subset of functionality for just one level, basically. So navigating in the scene tab is pretty easy. You're going to be using mostly your mouse. So if you're on a Mac, it might be a little more difficult for you since Macs are by default single click. And Unity supports up to 3 mouse buttons, a single mouse button, which if you click and drag around, you'll get this selector and you can sort of drag it over stuff and it'll start selecting them. It's got a right mouse button that lets you look around, just click and drag with that. And it's got a middle mouse button which lets you sort of pan. So all of these are really nice. But I think that the most intuitive way to navigate around your scene, and this is something that isn't really well explained in some of the tutorials, you can actually right-click and hold, and then you can use WASD to move around your scene, sort of just like a first-person shooter or a first-person game. You can also use Q and E to move up and down in your scene. So you can see this sort of floating camera icon, this infinite plane, and sort of off in the distance it fades to some pretty sky texture. So right now our scene is mostly empty, and we want to put a couple things in it. So the first thing that we're going to focus on is where things go when we make them in our scene. So there's a really tight correlation between this scene tab here and your hierarchy tab. Everything that's in your scene is represented visually, and everything in your hierarchy is just the sort of data representation of that. So you can see we've got a main camera and a directional light in here. So your directional light is this entity in your hierarchy, and your main camera is this one. And when you select them, they'll bring up a little bit of debug GUI for you, so you can see what's going on a little bit more easily. The hierarchy lets you select individual objects the same way you can in the scene view. You can click on them in either place, and it'll select them everywhere. So let's click on the camera, and we can check out probably the third thing that catches your eye, the inspector tab. This is full of a bunch of different configurable variables that are all pretty confusing and not really intuitive at first. But the inspector exists to provide information about what you currently have selected. Unity uses a component-based architecture, so everything in your hierarchy has some sort of data representation that you use to interact with it and modify it and change it so that it fits what your game needs. So here for the main camera, every single entity will have a name up here. So this one's just main camera. You can put tags, you can have layers. Every single entity will also have a transform. This is just its position in the world. This makes it much easier to manipulate it in the scene view. So I guess the first thing that we're going to do is we're going to move around this camera. And there are a couple different ways that we can do it. Because this inspector is just sort of a different representation of what's going on in your scene, we can modify them in either place. So we're going to try moving its position a little bit. So the first and probably easiest way to move around your camera is to grab one of these handles, just click on it, and you can drag it, and you'll see that your position value is changing over time. And that's because wherever you move it in the scene just directly maps to the inspector. And same way that you did that, you can change the values in the inspector directly, and it'll change what you see in your scene view. So these are really just representations of the same data. Because everything does have a transform, you will be able to modify it with this. There's totally a name for this, like three-pronged bit, but a what? A gongle? Dongle? That is such a lie. It is not a dongle. All right, we'll call it handles. So you can grab these handles here. Unity has a couple different ways that you can modify them, and that's what a bunch of these buttons are for. So right now we're on the dongle icon, but if we click here, we can change it to a rotation sphere, and this has drawn out the different axes that it can rotate around. So you can rotate your camera pretty much any way you want, or just grab somewhere on the sphere and rotate it like this. You go up here and you hit this button to activate your rotational dongle. These also have keyboard shortcuts. These are all mapped to QWERTY. So W will be your regular positional dongle, and E will be your rotational dongle. We also have a scale one that you can get by hitting R or by clicking up here. And this will scale whatever you have along each of the axes. For the camera, this won't do much because the camera ignores scaling. It does a lot of special work behind the scenes, so it doesn't need to use scaling at all. And this last one is a dongle for 2D GUI. We won't be using this as much because we'll be dealing mostly with 3D objects, but if you do Unity 2D stuff, this will probably be useful to you as well. And finally, we've got just a pan hand that we can use to move around the scene. So those are the basics of how to navigate in the scene view and what the connection is between all these three different things. So got to scroll down on my lecture notes real quick. So the next thing that we're going to want to do is obviously fill this with something. So first things first, let's just reset our camera to its defaults. The defaults for a camera are pretty simple, just X0, Y0, Z, -10, and then 0 for rotation and 1 for the scale on all axes. There are a couple different reasons why this is the default, but we just won't worry about it for now. So then we can navigate back into our scene view. We've got a directional light here. We'll just ignore that for now because we want to make an object in our scene view. So the first thing we're going to do is make a new game object. We're going to make an empty game object so we can sort of construct it from the ground up. So the easiest way to do this is just go game object, create empty, or hit Control-Shift-N, whichever suits your fancy better. And you'll end up with this sort of empty looking dongle in the middle, and you'll have game object selected in your hierarchy. This will come in with a default position that's sort of a bunch of random numbers. For now, we can just set this to 0, 0, 0. So you can sort of see that it's moved exactly to the intersection of these two lines here. Those are both 0, and it's also 0 on the y-axis. So it's right at the origin of our whole scene. And we want to display something, and Unity's got a lot of utilities for this. So the first thing that we're going to want to add is pretty simple. It's going to be called a mesh filter. So it's in rendering. Let me see. Might be in mesh. Yeah. Just go mesh filter. And then we'll get a mesh filter on here. And nothing looks like it's changed so far. So we'll need this. This sort of adapts whatever models that you're importing or geometry data into Unity's internal format so that it can render it. So it comes with a couple built-in ones. We'll get more familiar using Unity's UI now. We can hit this little target to the right of mesh, and it'll bring up a window for us that allows us to select a mesh. For now, let's just pick a cube because it's pretty basic. These are a bunch of built-in ones. So if you double click it, then cube will appear here in your mesh. And then we'll want to add a second component. This is going to be under rendering, and it's going to be, unless they moved it again, because they moved a lot of stuff in Unity 5. Yeah, let's try mesh again. Yeah, mesh renderer. So mesh renderer is the second piece of the puzzle, whereas our mesh filter takes some data and turns it into Unity's internal format. Our mesh renderer takes that internal format that Unity has and renders it to the scene view and in your game view. So right now, our mesh renderer is pretty default. It's completely fuchsia, which is kind of ugly. So we can change this by twirling open this materials here. And this will change what materials we have on our mesh renderer, and it'll change how it renders that data that Unity has for it. Right now it's none, so just click the target next to it. And it'll bring up a couple ones. For now, let's just click default diffuse. And now our cube is no longer bright pink. So definitely making progress. Question?
Why is the cube this disgusting fuchsia color?
Great question. So the question was, why is the cube a disgusting fuchsia color? And the answer for that is a little bit complicated, but what it really all boils down to is this material here controls how the object is shaded, which is a little bit more complicated and a little bit more complex down the pipeline of how things are rendered in game engines. But this default diffuse is called a shader, and it takes all of our data for our object that's been turned into the pixels for it, and it says, what color should this pixel be? So if we don't have a shader on it, Unity defaults to one that turns them all pink so that it sort of glares at us and says, you're probably missing a material on this. So when we set it to diffuse, then it looks around and it says, hey, there's a light up here that's pointing in this direction. I should use this to calculate what color mine are. Yes, so if I import a model from Maya, will it import the materials and textures? This is sort of hit and miss. Maya will import most of your stuff into Unity directly, so it should work most of the time, but notoriously materials and shaders that you build in Maya will not be compatible with Unity. And this is mostly for performance reasons, because Maya is made as a generic modeling tool. It's made to go for everything from, you know, I want to make a simple 3D game to I want to model for Disney, and I want to make really high polygon character models that have tons and tons of data, more than you would ever want to display for a game. So its shaders, which it uses to color your object, can also be pretty wasteful. So that's why we don't import them by default from Maya. Sometimes you have to lean a little bit heavy on the magic of Unity's import pipeline, because a lot of work went into that for a very good reason. So this is, it's a pretty good start. We've got something rendering here. This is a good time to look at our game tab. So if you click on the game tab, which should be next to scene, then you'll sort of see that you've got this big white square in the middle, and then you've got the sort of the background skybox with a gray ground and a sort of bluish sky. And the game tab is really, really simple. It is basically just what your camera is seeing. So if you click on your main camera, it'll make a preview for you in the lower right-hand corner. And this is exactly what your game tab sees if you switch between them. So the game tab is just what the game is seeing from the camera's perspective. So if you get it positioned right over where your camera is, you'll get pretty much the same rendering. Question?
How do you get the camera preview again?
Just click on main camera in the hierarchy. Yep. So we've got a couple things rendering. This is pretty cool, but it's really not a game that much. We'll have to do a few other things before it gets anywhere near interactive. So let's add one more component to our game object. Right now, it's got a mesh filter, so it can turn some data into Unity's internal format. It's got a mesh renderer, so we can render that to the screen with a couple of shaders that we tell it to use. We'll also want to add a collider to it, which interacts with Unity's physics system. So just go add component, we'll go physics, and we'll put a box collider on it. And at first you might not see anything different, but if you look really closely, you'll see this thin green line around the edges of your box. If you can't see your collider, that's probably a very good sign. That means your collider is fit mostly exactly to the same shape as your mesh. We can see it a little bit easier if you hover over mesh render here and then find the checkbox next to it and just turn it off. That'll stop the mesh renderer from rendering the mesh, and it'll make it so this box collider shows up a little more clearly. So it's easy to see that this box collider, it's not actually the rendering part. It's just this sort of imaginary collision bit to it. So you can turn that mesh renderer back on, and then that pops back in. So that checkbox is how you enable and disable these components that we've added to Unity so far. You can disable your box collider, and that thin green line will go away, the same way that we disabled the mesh renderer. But that's basically how to make an object in Unity. So the next thing that we're going to want to look at is going to be the project tab. So down here we've got our project, and it says assets right in this little window over here. Your assets folder is a default folder in your project, and this is where most of your things that you make for it should go. This includes scripts, textures, all sorts of sprites, 3D models. So it's important that you keep your assets folder pretty neat and tidy. You don't want to accidentally lose track of anything that's inside of it. A really good way to demonstrate stuff that gets put into your assets folder is by opening your assets folder. So just right-click in Assets, and then click Show in Explorer or Show in Finder if you're on a Mac. And it'll bring up your current project hierarchy in your Windows Explorer. And this is your assets folder. So everything that's in here is also in this little window pane down here. So one thing that we can add to our scene, we've worked really, really hard on our box, and we don't want to lose this. Maybe we want to make more copies of it. So we can drag it down here into assets, and this will create a prefab for it. A prefab is short for a prefabricated object. It's basically just the data that was in this object as a file. So if we check out our assets folder again, we've got this new gameObject.prefab file. And that prefab has all the same properties as the original object. And if we want to, we can make a copy of it by just dragging it back out into the scene. And we can make a second cube, we can make a third cube, as many as we want. For now, we'll probably only want one though. So you can select them and hit delete to get rid of them. All right, so now that we've got most of the stuff that we need, let's go into the physics system a little bit more. We've got one cube here that's pretty neat. It should have collision enabled on it, but it won't quite interact with the physics system just yet. We need to add just one more component, so go add component, and we'll click physics, and we'll want this Rigidbody component. And the difference between this box collider and a Rigidbody is the box collider is just in charge of checking whether or not two colliders have contacted each other or are intersecting each other. And the Rigidbody sort of holds all the properties of an object like you might learn in physics class. It has mass, it has drag, it uses gravity or doesn't. If this is kinematic checkbox is checked, that means that it'll just stay completely stationary and it won't, it'll ignore anything that happens to it, even though other objects can run into it and like hit a wall. And it's got a couple other properties that are a little bit more advanced. But basically what this Rigidbody does is it links our object into the physics system and it says, go ahead and drive this object. You can change its position over time if it's supposed to be falling according to gravity. So if we switch over to our game view, we can finally hit this giant play button and hopefully we'll see our box fall, which is awesome. It's a falling box. Put it on the App Store. We can see this stops if we right-click on our Rigidbody component and remove it. Instead of falling, our box will simply stay still, nothing happening. So we'll put that back because we want stuff to happen to it. Oops, put a second box collider on it. All right, so let's get started making something kind of simple. The goal of this workshop is going to be to get a very simple ball rolling around on a flat surface. So this box could be a flat surface if it wasn't, you know, so perfectly cubic. We want to sort of stretch it out in either of those directions. So let's grab our scale tool, and we can grab these sides of the scale tool to scale our object along each of those axes. You'll see our scale property in our transform change, and we can make it a little bit thinner too by scaling down this green y-axis. So now this looks a little bit more like a floor, which is probably more of what we want. Since we've got our Rigidbody on it, this means that our floor is going to fall. We obviously don't want this, so we can check it as a kinematic, and we can tell it, don't use gravity. And now when we start our game, it should stay perfectly stationary and really hard to see because it's so close to the horizon, but it's this big, long, flat, white line. So obviously, our game view is not helping us out too much. We want to get something like this really cool dynamic view where it's like, wow, look at this floor. And this will bring out one of the cooler things that Unity lets you do. Because this scene view is really just a representation of some data, we can take some stuff that we have in the scene view and we can set it in our inspector without having to type it in manually ourselves. The coolest way that we can use this is by selecting our main camera and going game object, align with view. And what this does is it takes the transform of our camera, which we've selected in the hierarchy, and it sets its transform exactly the same as how we're looking at it with our scene view. So if we like back up a little bit, our camera is where we were just looking from. Our camera preview has the exact same properties as our original view, and if we switch to our game view, it looks a little bit neater now. So this is also pretty cool. And we're a little bit closer to getting some basic stuff happening. So let's start making a ball that we can roll around on this surface. So this is going to be a lot of the same processes as the original one. We're just going to hit Control-Shift-N to make a new game object. Now we've got two game objects. It's probably a good idea to rename them. So let's call this one ball. We can name the other one floor. So our floor is all set up. Our ball is going to be most of the same stuff. We're going to want to add a mesh filter. This one we're going to want to be a sphere. And we'll also want a mesh renderer. And now we've got a big purple ball. So we'll switch back to our position dongle, and we can move this around. We can move it in a plane, the same way that we've been moving it along an axis. Just instead of grabbing these arrow dongles, we can grab these big flat ones, and this will move it around just in one plane. So we can pick a good place for it, put it roughly in the center, and then we can set its material so it doesn't look quite so pink. And we'll also get the shadow for it. What's up? Oh, really? Okay, so Spencer warned me that a couple people might have orthographic views right now. So when Unity moved over and started supporting 2D a lot more, we have this quick toggle between 2D and 3D modes. So if we hit 2D, then we'll get this scene view where it's sort of side on and not really helpful. If we click it, we'll go back to whatever we were looking at. This is helpful if you're working in 2D, where you want everything to be flat and sort of constrained in that plane. But when we're in 3D, that's not going to be so helpful. And if you accidentally started with a 2D project, you'll need to change your camera to a perspective camera instead of an orthographic camera. These switches are just under main camera, and then the camera component, and then this projection property. We can play around with this too and see the differences between an orthographic perspective. So this looks kind of wacky, and it's because there's no foreshortening. When things get closer to you in a perspective projection, they get bigger, and when things get farther away from you, they sort of pinch off like railroad tracks leading into the horizon. But in an orthographic view, it sort of just takes all those and then sticks them flat onto your screen without making sure that things farther away get squished. Yes, so if you've played a lot of isometric games, this looks a lot like what an isometric game would look like. Yep. So 2D games are almost required to use an orthographic perspective because they don't have any depth to them. So you can't really shrink things that are far away, because what is far away? We don't have a third dimension in 2D games. But in 3D, we sort of get the benefits. We can use either of them. So if we change it back to our perspective, this looks a little bit more familiar. And this is how it actually looks, as if you have an eyeball instead of like a 2D eyeball. So that's the difference between orthographic and perspective projections. You can sort of see in orthographic, this end part looks about as far from the camera as the closest part. So we'll want that on perspective for ours. But if you like orthographic, by all means, try to use it. It's super stylistic and awesome.
I'd also like to add, you can also change your view, just the view of what your editor looks like, by clicking the white box in the dongle in the top right of the scene view.
Which one? This one?
No, go in the scene view. And you see your axes up there, you can click that cube there to go between perspective and orthographic. And it's not changing anything except for how you view it. I noticed some people were in orthographic, that's why it might look a little odd to you. You probably want to work in perspective for this tutorial.
Yep. And so you can sort of see this seems really weird in this orthographic view. Sort of kind of trippy. So we'll want this in perspective. And this is much better. So we've got our ball. We just need to add one more component to it. Well, really two more components. We'll want to add a sphere collider instead of a box collider. That's going to be under physics sphere collider. And you'll see we'll get this same sort of green outline around it. That just indicates that there's a collider on it. and we'll want to add another rigid body to it. This rigid body we don't want to be kinematic because we want it to roll around. And now to try to get some action out of it, because we want to do anything cool, let's grab our floor, switch to our rotation dongle, and give it a little bit of a tilt. And then grab your ball, grab the position dongle, and move it to the top side of the plane. So now, from our game view, we can sort of see our ball's at the top of this ramp, and when we play, it will just fall down and then fall off. So you can hit play again to stop playing and go back to the way that it was in the scene view. But there we go, our first little bit of action in the game view. So that's really cool. Let's set our floor's rotation back to 0. That way it's flat, and we'll move our ball back into the center of it. And now we can get into a little bit of scripting for Unity. So in a very basic game, something like Super Monkey Ball or some of those marble games where you have to control a marble and not fall in any holes, the basic control is you just move it around on a plane. So let's try to get it so that we can give some input and have this ball move around on our plane when we play, instead of it just sitting there and doing nothing. So we're going to need to do some scripting for this. Luckily, Unity's scripting system is pretty straightforward. First, let's make a prefab of our ball, same way that we had a prefab of our floor. And then we're going to make a new script. You can just right-click, create, C# script. We're going to be using C# for most of our tutorials because C# is widely supported by a bunch of different programming environments, and some of the other scripting languages aren't as well documented as C#. So this one we'll just call movement, and then hit enter. When we've got our movement script, you can get a little preview of what it looks like. But just by a quick show of hands, is anybody familiar with C# already? Is anyone familiar with C++ or C or any of that family of programming languages? Yeah. Yep. If you're taking data structures, you're probably on the way into that deep dive. So we will want to open this in a text editor. So we can just open this. It will probably open Monodevelop. So Monodevelop is an IDE that comes prepackaged with Unity. IDE just stands for Integrated Development Environment. It's basically a really fancy text editor with a little bit of bells and whistles. It comes by default, it's set up by default, and it's pretty good, but there are a bunch of alternatives if you like Visual Studio. Visual Studio recently got the stamp of approval by the Unity developers, and you can integrate Visual Studio with Unity pretty well. For now, we'll just use Monodevelop or a basic text editor like Notepad++ if you don't have Monodevelop. So let's go through and explain a little bit of this code. These first two lines here that say using Unity Engine and using system.collections, these are import statements. They basically say we're going to be using a couple libraries that aren't built into the language by default. This one is Unity Engine. This contains all the stuff that Unity has to offer us from our scripting side. And system.collections is just a C# library that we can use to make lists of things, to make dictionaries, and a bunch of other stuff. And we'll probably be using those more later than we are right now. And then the meat of our file is this class movement. Public means that everybody can use movement. It's not restricted to a couple files or the specific part of the project. And a class is sort of like a box for programming. It lets you put a bunch of related properties inside of it and package them all up so you use them together consistently. So this class for movement would encapsulate stuff like moving the ball around on that surface, So that's what it's explicitly for. A good example of a class would be something like a pencil. A pencil might have properties like how long it is, how sharp it is, how much eraser is left, and we can sort of boil those down to some basic types, like a number for how long it is. Sharpness could be just from 0 to 1, like a percentage of how sharp it is. And the amount of eraser left could be like another number. So it kind of all boils down to numbers in the end. So for now, we just want to call it movement. And then we have this colon here, which means that we're going to be inheriting from. This is a little more complicated, so we'll just ignore it from now. But this mono behavior is another class that is from Unity Engine. And it gives us a lot of boilerplate code so that we don't have to write a bunch of stuff. So moving on, we've got this function here. This is the notation for a function. We have a return type. In this case, void means we aren't returning anything. Start, that's the name of our function. 2 parentheses, and then these curly braces. And we've got one called start, and we've got one called update. From these little comments here, comments are preceded by 2 forward slashes. This just says use this for initialization, and update is called once per frame. So in here, we're going to make a couple different things. So if you want to follow along, this is on the wiki, if you don't want to have to squint really hard at my code. But the movement class, we're just going to have, yeah, can I do that with Control Plus, or? Yeah, I'll make it bigger.
Yeah. You also might want to put it on Oblivion so it's easier to read. You gotta go to Tools.
Tools, yeah, we're gonna change. This is options. This is one of the ways that you can sort of personalize it. Probably general syntax highlighting. Yeah. So this is just one of the different ways that you can view the text in Monodevelop. We're going to switch to Oblivion because Oblivion is a little bit easier on the eyes, especially if you're staring at a computer screen for a very long time. It's a darker one. So still all the same stuff, just a couple different colors, and instead of being mostly white, it's now mostly this dark gray. So if we think about how we want our ball to move, we basically want to push it in whatever direction that we're holding down on the arrow keys. And that's something that we're going to want to do roughly once per frame. We want to do it over an extended period of time. So this is going to involve checking our arrow keys or WASD to see if we've pressed left on them or right, forward or backward. It's going to involve figuring out what force that we want to apply to our object and move it around. And then it's going to actually apply it. So let's get started. We're going to learn a little bit about types. So in C#, first thing that we're going to want to add is public vector2 speed. And we'll start this off as saying equals new vector2 2020. So this is just saying that we're adding a new property to our movement class. So we're saying whatever this movement is, it has some speed property. And when we make a new movement component in Unity, it's going to start off with the default values of 2020 for it. A vector2 is just a 2D vector. So back in algebra, you have your x-axis and your y-axis. A vector is just some difference between 0, 0 and another point. So when we say 2020, this really just means a vector that goes from 0, 0 all the way up to 2020. In Unity, a little bit more concretely, if you zoom in far enough, you can see these individual blocks in here, these big squares. Each of these is 1 unit long on each side. So when we say 2020, that's the difference between this right here at 0, 0 and over there, because each of these larger blocks is 10 on each side. So our vector is literally from here all the way over to here. So this is going to be the speed that we want our ball to move at. After that, we're going to make a private property. This is something that is a property of our object, but we don't want people to be able to inspect. So it's sort of like hidden from everyone else. Only we're allowed to look at it and change it. So it's more of the sort of thing of what's going on inside the mind of your movement class. So while it definitely has some speed property, it might remember something like this direction vector. So this is something that it's going to keep track of. Nothing else is allowed to look at it, only movement. So then we're going to skip over our start function because we won't need anything in there. Our stuff is already pretty well initialized. So our update is where we're going to be doing most of our logic for our game. The first thing that we're going to make is a float in here. This is going to declare a new variable that only exists inside of our input function, and we'll call it input x. A float is just a value. It's basically just a number. It can vary from 0 all the way up to 70,000 or even more. But the more digits you go up, the less precision you have for the digits closer to 0. We don't really need to worry about it so much because we'll be using floats mostly for things from 0 to 1 or in a range of smaller values. So we'll say input x equals input dot get axis, got caps lock on, horizontal. So real quickly, input is something from Unity Engine, the same way that Monobehavior is a class from Unity Engine. And getAxis is another function where we tell it which axis that we want to look at. And horizontal is the one axis we want to look at. This will go positive if we press to the right or if we press D. If you remember from algebra, you got x grows to the right, y grows up. So to the right will be positive on our horizontal axis, and to the left will be negative. And we'll want to do the same thing for our y-axis, except this one's going to be vertical. So now we've got our input from left and right in A and D in horizontal, and we've got our input from up and down and WS in our vertical. And now we're going to update our direction. So we're going to say direction equals a vector 3. So we're going to tell it what values we want for each of those components, the same way that we sort of set with speed earlier. This first bit is going to be however much input we got from -1 to 1 on our horizontal axis times our speed, which is going to be that 2020. So if we're pressing left, it'll flip it around and say move -20 units along the x-axis. And if we're pressing to the right, it'll say move +20 units on the x-axis. We'll put in 0 for our y. Since y is up and down, we don't want it to move up and down. We want to move it in this xz plane instead. If we go back to Unity real quick, we can see we've got this x-axis that goes this way. We've got a z-axis that goes this way. And our y-axis is the one that's up and down. So we would use the y-axis when we wanted to jump, rather than when we want to move forward and backwards. So left, right, forward, and backwards. So for our z, this is where we're going to use our input y. All right, so this is just going to update our direction. So it's going to be somewhere in that 2020 range, negative to positive. And finally, we'll add a new function called fixed update. This one is a lot like update, except whereas update is called once every single frame, Fixed update is called kind of irregularly. Fixed update is called by the collision system and the physics system. So anything that we want to modify related to physics should go in fixed update. Otherwise, we have a chance to mess with it and screw things up pretty badly. So here's where we want to update our velocity. So let me see, I probably need to do all right, so this is the real meat of actually moving our object. This get component here is a function that Monobehavior has. And when we say get component rigid body like this, it means look on our game object for some component that's a rigid body and then give it to me so we can modify it. And then the rigid body has a function called add force that we can use to give it a little push in a direction. So we're just going to add whatever our direction value is as a force. So this is all we need for our movement class. Just save it with Control S or File Save and go back to Unity. And we can check our console to make sure that everything compiled properly. If we add some stray characters on accident, like that, and go back to Unity, should yell at us. Might need to be on something. What was that? I think I did. Oh, maybe I didn't. There we go. So it'll give us a little compiler error here. So it's always checking your code to make sure that you typed it correctly. So I'll go get rid of that so we can start using it.
Did anybody get any compiler errors who might need help?
Yeah. Is everyone at this stage so far? Raise your hand if you need a little bit of help to get to this spot. Yep. It'll be in the console tab. So next to your project tab, there will be one called console. It should be empty if you don't have any errors. Okay. So now that we've got our movement script that we spent all this time writing, we can finally start doing something with it. So the same way that we have components for a mesh filter and a mesh renderer, a sphere collider, and a rigid body, what we just wrote called movement, this is also a component. So we can put it on an object the exact same way. So we just go add component, and then scripts, and then movement. Yes, or you can drag it from your project into the inspector, and that'll add your component directly to the object. So now you can see the speed property that we made public so that everyone can see it is displayed down here. It started at 2020, just like we wanted. And it says that our script is movement. So our script is on our ball, and when we go to play, we can now move our ball around with the arrow keys, or WASD. So go ahead, go into play mode, and try moving your ball around.
And if anyone falls not moving, raise your hands up, yes.
Okay, so I'll run around and help a few people real quick, and then we'll start right back up. All right, so pretty cool, right? We got a ball that we can move, and its physics feel like really gross, and it's super slippery, but it's also kind of fun. It's kind of like Super Monkey Ball. And you've got this like platform that you can fall off into oblivion and never get your ball back. So that's like some like risk reward going on there. So overall, kind of fun, right? So the next thing that we're gonna want to do, haha, Spencer. So the next thing that we're gonna do is we're gonna try making this into an actual game. I know it's like scary because we're already making games. What's wrong with the youth of today? So let's try for a relatively simple game. What we're going to do is we're going to have our ball roll around on this surface, and we'll have obstacles that you can run into and holes that you can fall through. And we'll just make the goal to get from one end to the other. So this is actually going to be pretty easy. Let's grab our scale tool again, because we're going to need a much wider area for our ball to roll around in. Make it a little bit deeper like that too. So we'll make it a big and wide level and move our ball all the way to one end of it. So now we've got our ball. Our goal can be to get the ball from one end to the other. We could make it so that the camera just looks at it from the front or the side or even the top, but these are all kind of boring and not really easy to see what's going on. So we want to make our camera follow our ball around. And this isn't going to be too difficult. It's pretty basic what we're going to do. So let's move our camera to where we roughly want it to stay by our ball. We want it to be x-axis to the right and z-axis forward. So I'm going to resize mine or rotate it. We'll make it long this way. Move it over our ball and grab that. All right, so if you missed what I just did right there, all that I did was make sure that we have our x pointing to the right, our y pointing up, and we're behind our ball right here. And now we're going to grab our main camera, and we're going to tell it to align with view again. So we've got roughly where we want our camera to stay behind our ball. What was that? Yep, to align with view, go to Game Object, Align with View, while you have main camera selected in your hierarchy. So we've got our camera preview, looks about the same as what our scene is. So now we want our camera to follow behind our ball. A cheap way of doing it is making it a child of our ball in the hierarchy, but I'll do this real quick so we can see why this isn't going to be a very good idea. So to make something a child of an object, you just grab it and you drag it over, and you'll see now ball twirls out to have main camera inside of it. And at first this seems like, great, it's going to stick behind our ball, except now our camera is going to spin when our ball spins, which isn't such a good idea. And now it's going to roll when our ball rolls. I mean, it's really cool, and it'd be great for an indie game, but this is probably not what we're going to want in most of the cases that we're going to be using it. Yeah, there we go. We made vomit marbles. So this probably isn't what we want, so don't want that main camera in there. To get it out, if you put it in, just grab it and then drag it into some empty space. So what we're going to want to do with this is some more scripting for it, a little bit more of behavior for it. So the same way that we made our movement script, we're just going to go create C# script. We'll call this one camera follow. This one's going to showcase a couple more really cool things about Unity, so let's get started writing the script. If you switch back over to Monodevelop, camera follow should appear on the left here. If it didn't show up immediately, it might take a little bit to refresh, but then double click it and you'll get this camera follow script. So when you have camera follow open, we're going to start with some really easy ones. Let's make another public vector 3, and we'll call this one displacement. This will be how far away from the ball we want the camera to stay. And then we can make public transform ball transform. And this will be the transform of the ball that we're following. So now in update, this is where we want to change our camera's position over time. It's going to be a pretty simple calculation. We'll get our transform component, which all game objects in Unity have, and we'll say position, and we'll set that position to the position of our ball plus our displacement. And that's all that we really have to do to get it to follow our ball. This will stop our camera from wiggling around and rotating and stuff. So this will give us more of the behavior that we're looking for. So I'll wait a few seconds to get this, to let everyone get this typed out. So this is, again, pretty simple, basic logic for this. The cool part is going to be setting this displacement and ball transform. If you've worked with programming languages before, you might be sort of looking at ball transform and saying, well, how are we going to get that to be our ball that we're following? And this is one of the cool things about Unity. So now that we've waited a couple more seconds for everyone to get this typed out, we'll switch back to Unity. First things first, make sure we don't have any compiler errors. And now we can go to our camera, and we can put our camera follow script on it. So now we've got camera follow as our script. Our displacement starts as 0, 0, 0, and our ball transform is none. But what we can do is we can just take our ball that's in our hierarchy and drag it to ball transform. And now the ball transform of this camera follow script is going to be this ball. So for our displacement, we probably don't want it to wiggle back and forth across the x-axis much. For the y-axis, let's try somewhere around 10 units up. And for the z-axis, we want to be probably around 10 units back. So -10 on that one. And so with these on our script, we can go ahead and try it out and cross our fingers that we get the results that we want. So I'll leave this up for a few more seconds. And we'll run it. And now when we move our ball, our camera follows behind it without turning it into Vomit Marble 2015. Yep, so I'll bring up that code for camera follow one more time. So now we've got this pretty, it's getting closer towards the game. Our ball can move around. We've sort of got this long track for us to go along. We roll off the end and we plummet into oblivion forever. So this is getting closer, but obviously Super Monkey Ball has got some kind of obstructions. So this is where we want to start building more of our level. So let's make, we're going to want stuff that's almost the same as our floor. So since we've got this game object that we made at the beginning that is a perfect cube, we can just drag this back into our hierarchy or drag it into our scene. And we'll make a copy of it. And now we can start positioning it on our playing field so that our ball can run into it. So if we want to make a wall here, we can take this cube, rest it just on top of our platform, go to our scale tool, make it wider, and move it off to one side and a little further ahead. And then here we might want to duplicate it a little once or twice and make these sort of zigzags that our player will have to go through. To duplicate an object, just right-click on it and duplicate. So now that we've got roughly 4 of these, we can try our ball game again. As you might be seeing, it's getting a little bit hard to see everything. So we're going to start messing around with some colors here. That shader that we talked about earlier that determines the color of things, the same way that it can make things pure fuchsia, we can pick a color that we want to make things. So here, let's just go right-click in your project assets, go to Create, and instead of a shader, we want to pick a material. A material is to a shader sort of the same way that a component on an object is to the script that we wrote. A material is an instance of a shader with a bunch of variables that we've set on it. So here we'll just call this red. And on here, we'll change our shader to, there should be a diffuse here on here somewhere. Might have to go legacy diffuse. Let's try just changing our albedo. All right, so click on your albedo here. These are all kind of complicated, so we won't worry about them for now. This will bring up a color selector. Pick red or something reddish or something kind of artsy red. I'll use pure red. Yep, to click it, click on your red material in your project assets, then click on this albedo selector. Yeah, to create it again, right-click, create material. So now we've got this red material that looks like, it should turn things red. So let's turn our floor red so we can see things a little more easily. The same way that we set this default diffuse on here, we can change this to our red, and it'll turn our entire playing field red. So it's a lot easier to see our ball and our 4 little pegs that we have to maneuver around. And of course, because we're making indie games here, we gotta choose that artsy red, like super hot. See, you can't really tell if it's magenta or red, so it must be art. Yep, so sorry if I went over that a little bit too quick. You can click on floor, then go into your mesh renderer, and where we have this element 0 that was previously default diffuse under mesh renderer materials, we just want to drag our red into there. A much easier way to do it is to just grab your red and then drag it directly onto whatever you want to color red. So if that method's not working for you, you can just drag it out into the scene or onto an object. And you can pick a different color. Like if you want to be like incredibly artsy, you can keep calling it red, but actually make it blue. What is red? Is my red the same as your red? Oh, I can't name it red with a question mark. So now that we're here, when we start playing our game, it should be a little bit more like a game. We can actually run into these walls and we have to maneuver around them to get our marble to the end of the field. And then we fall off the edge into oblivion. Yeah! And then we die. This is truly art. So everyone should be here. If you have any questions, just raise your hand. We'll be around and help you real quick. So now we've kind of got a sort of marble game. This is looking pretty good so far. We've got our little obstacles in the way. If we wanted to, we could even make cool little bits like, let's grab our game object here, our last one, and duplicate it again. And now we can make a ramp the same way that we made these, just by squashing and stretching them. So let's make it pretty long like a ramp, maybe a little bit thinner. And then instead of lying it flat, we'll grab our rotation tool and tilt it up a little bit. Too much art. I think we only want X rotation. Okay. So just give it a little bit of tilt on the x-axis. And now we've got a little ramp. Scale a little bit. Move it back down. Now it looks like a real ramp, even though it is sticking out the bottom like that. So now when we play our marble game, we can go around. Try not to fall off the edge. And now we can also go up our ramp and off the edge. It's the good ending. Our ramp is just one of these blocks, but super fat along, super tall, a little bit less wide, and then also long. Then we just took it and we rotated it so it's sticking half out of the ground. And to make sure that you get this nice clean edge here and you don't end up with a diagonal, just make sure that your rotation is only along your x-axis. You can just set your y and z to 0. So now we've got a ramp, we've got some obstacles. This is all really cool. So let's make a little ending area that we can try to get to. Same way that we did these. Just duplicate again, move up a little bit. We want this to be flat. I think it's Control-Shift-D, but I'm not sure. Just Control-D? Try Control-D. So we'll make a little ramp here that we want our player to end on. And then we'll add a little bit of text at the end to let them know that they win. Because if they don't know that they won, then they'll just go back to the beginning. So we'll want to make a new 3D object, 3D text in here. To get here, just right-click in your hierarchy. And instead of making a new empty game object the way we've been doing, just go 3D object, 3D text. And then you should end up with this empty looking area the same way. It should say hello world. If you've done some programming before, you're probably familiar with hello worlds. It's pretty much what the default text is for almost everything. So then just put it at the end. And with your text selected, go to text mesh, and you can change it to you're a winner. In the same way that we've changed everything else, you can also change the color of it. Artsy orange. Go orange red, right there. And if you don't like the default font, you can pick from nothing else. Deal with it. So you can get other fonts in Unity, but by default, only Arial is supported. You can get other fonts just by grabbing a TTF for them or an OTF and adding them to your assets, and then it'll pick up on the font and it'll let you select it. So we've got some text here. I wonder if we can make it to the platform. So let's go ahead and try out a very simple marble game. Might want to make a wall there eventually. Yes. Was it like 2? The font size? Where's font size? Oh. Well, 0 times 10 is 0. You mean I need to shrink it? Like this.
You want to keep the scale on 1. That's stupid, but that's the best way to do it.
All right, so now we've got our high resolution text. If you missed that, you want to bump up your font size a lot and your character size down a lot. And now when we play our marble game, we can see our text. We can see that we want to be winners. Obviously, if we go around our ramp, we can't get up there.
Winner's not you.
But if we get up enough speed, we can win. So there we go. Really, really basic marble game. You can continue adding to this. There's a lot of room to expand on this game. It's a pretty simple concept with this basic level. Not much going on in it. It's easy to make a lot of new obstacles. So if there are any questions, just raise your hand. If you have ideas for what you want to try out, just let me know. We can try them out. That's a good idea. So we could add some collision detection. So if you bump into a wall, that it'll send you back to the beginning. If we want to try this, we certainly can. So yeah, so for text, to make some text, right-click on your hierarchy and go to 3D Object, 3D Text. And it should make a new bit of text with just the words "Hello World" in them. To change that, just go over to Text Mesh Text and change it. And you can also change the color. So now we've got our marble game. It's mostly a game. It's pretty fun. But what if we want to add, like was suggested, a little bit that will send the player back to the beginning when they bump into a wall? This is a pretty good idea. It'll make it more of a game. We'll actually have to try to avoid our walls. They become more like dangers to us than they do obstacles. So let's check out exactly what we want to do. So we've got our 4 walls here. And when we bump into them, we want the player to say, hey, I need to go back to wherever I was at the very beginning of the game. So this is going to come in roughly 2 parts. The first part is our player is going to need to remember where they start at the beginning of the game. And the second part is when we bump into a wall, we need to check that it's a wall. And then if it is, move us all the way back to our starting location. So this is actually not too difficult in Unity. So we'll go ahead and we'll try it. So first things first, we're going to have to modify our ball class again, our movement class. And here, let's just make a new private vector 3 starting position. And in start, we'll say starting position equals get component transform dot position. So all this is doing is we're just storing the position that we start at in our starting position. And let's add a new function. We'll call this one reset position. And all we're going to do here is grab our transform again and set its position to our starting position. So if we call this reset position function, it'll move us back to where we were at the start of the game. Then we're going to hook into another one of Unity's preset up functions, like start, update, and fixed update. This one is going to be called on collision, I think it is. I think it might be on collider enter. Okay. This is probably also a good time to showcase the Unity docs. I think it's collider enter. Okay, you were right. So this is the Unity documentation. So we've got collider.onCollisionEnter. So this is called when one of your colliders bumps into something. So here we've got an example on collision enter with, oops, went forward. Too many buttons on this mouse. We take in a collision object, and then we can check what object we've bumped into by looking at our collision and getting the game object on it. So what we're going to want to do in here is on collision enter, collision, collision. And we're going to say if collision dot game object, so if whatever we bumped into dot tag equals wall, then we'll call reset position. So this tag property is one of the things that you can set on a game object. As you do more and more with Unity, you might want to use tags less and less because you can only set one per game object. So in cases where we'd have a bunch of things that want to have like 2 or more tags, it might not work as well. But for now, we'll just use this tag property. So when we run into something that's labeled a wall, we'll reset our position. Yep, so I'll leave this up for a little bit. Let me check that I don't have any compiler errors. Yep, I'm good. I'll leave that up a little bit longer so anyone can type it if they haven't yet. All right, so now in Unity, what we want to do is, that was all modifications to our movement script. Those will be automatically updated on our ball. What we do need to do is we'll need to set our tag for our walls here. So click on one of your walls and go to the tag property and select add tag. And here you'll be brought to one of the things for editing Unity's internal stuff. So here is this list of tags. Just click plus and name it wall. So now we've got a new tag that we can put on things called wall, and we can tag it as a wall now. So just do this for each of your game objects that you want to detect. And then we'll go ahead and hit play, keep our fingers crossed, and there we go. When we bump into a wall, our position for our ball resets. Just like that. So just raise your hands if you need any help. I'll put that clip back up. The edge, and then I want my ball to reset when I fall off the edge too. So we'll do two things. We'll make it so when we reset our position, we also make it so our ball stops. That way if we're running into a wall and then we reset our position back, we won't keep going forward just as fast. So here in our reset position function, we'll just add get component rigidbody dot velocity equals vector3.0. This just makes it so we stop moving when we reset our position. Pretty easy. And then in our update, we'll add one little bit of code. If get component transform dot position dot y is less than, let's say, -5. Then we'll call reset position 2. So all these are saying are set our velocity to 0 when we reset our position, and if our current y position is below -5, then we'll also reset our position. So if we look here, this is y equals 0 right here, so down -5 is probably somewhere like right here-ish. So we'll check our console, hit play, and make sure that it works. And we reset. If we run into a wall, we don't keep that extra velocity. So I'll bring that code back up so that you guys can look it over. But that's all that we need to add. And we basically have most of a game so far. If you have any questions, just raise your hand and we'll be around. All right, so that's about all that we have for today. Thanks everyone for coming to our first Unity workshop. It's been a pleasure having everyone. Hope you really enjoyed making a marble game.